Hello, everyone. So, I was thinking about writing a very simple project in order to learn C programming language. And I thought, um, so the topics that I want to really cover in it is that how I can learn some data structures and how I can do memory management in C. Those are the things that I want to really learn because I've read about them like in the past 2, 3 weeks. And I really want to get some hands on experience with C programming language. So, I'm going to do it by writing a real project. So the project that I'm trying to write is a simple database, simple key value in memory database, which is going to have basic functionalities like adding something to the database as a key value pairs and then getting a key with its value. And I did some quick researches, but then I noticed this might be a very interesting topic to record and share in terms of like how do I my research, how do I learn this stuff, and how do I like use AI LLMs, let's say, or agents that I can really finish a project or like when I get stuck or struggle with something, how I use them. So yeah, it's just a journey. I'm not really trying to teach something. I'm not a pro in C programming language. I just do some backend development. But now I'm really getting really interested in system development and I really want to understand how the hardware works in terms of memory allocation, how this operating system handle handles like the memory allocation, freeing up, and how these system calls work. And those are the things that really got me, um, made me interested in writing programs in C and Rust, probably. So that's the background that we're coming from. So just for your information, I've done nothing. I've just searched some stuff, but I'm gonna do the research again so we can just have the same to be on the same page. That's the whole point. I have created a directory. I've called the project SimpleDB. I am not pretty much sure, but there should be a SimpleDB, an actual enterprise ready kind of database called SimpleDB. But this is not something that is going to be really similar to because it's a local, like a toy one that I just want to learn with it how to write a program in C. For your information, this project is not going to be an enterprise kind of product. It is just for learning purposes. So I'm not really promising any dedication on this project. It's going to be a toy one. Probably I will just push it on GitHub and then leave it at some point. So okay, let me just start with some basics so we get into on the same page before I start doing the strugglings. And let's start with drawing some stuff on a board so we know what are we trying to build. So let's imagine that we create a interactive kind of CLI or a program also. The CLI and the program is going to be as one program, of course. In a real world project, in a real world scenario, I would write a backend, something like the engine of this database, and then I would write the CLI as a separated program, which could communicate with the core engine in order to do the like perform the operations. But here, if we're just making everything simple, I'm gonna just do both in one, and we're gonna have something like simple DB, and when we run that, it's gonna be something like an interactive shell or a CLI that you can just add keys there, like add name Emot, and then it's gonna be okay. And if I do like get name, it should end in Emot. That's what we're trying to do. And as you may know, this is called a key value um, structure, key value database kind of thing. And there are pretty much good like tools and real databases like Redis, Memcache, Apache Ignite, if I'm not mistaken, that they do the same thing but with a very professional advanced kind of implementation. So that's what are we trying to do. But let's get into the point of storing these. First of all, as we already discussed, it's going to be an in-memory database. So if we just close the program, or let's say shut it down and rerun it, we're going to lose all of the key values that we've saved in the previous interaction with that program. So it's an in-memory one, no persistent storage. So that's the simple part of it. And let's start with how we should really store these key value pairs there. So first of all, I was thinking about something like linked list, but I'm gonna just I'm thinking loudly, and I'm gonna just walk you through the pros and cons of each solution, and then we can just get into the final one that is the correct one, and I will just show you why that is the correct one, and then we can just then probably read some documentations in terms of checking if you're following these standards, we're doing it in the correct way, and then we can do the implementation, the actual one. Okay, let's start with linked list. So imagine you want to store a object in memory, and then you're gonna have something like key, and then you're gonna have something like value, and then you probably will need to have the same like series of these blocks, and then you probably will connect these together in order to have this chain. So when you want to search for something, you can just follow the chain and find out what are you looking for. So this is called a very simple linked list kind of structure, right? So for example, if the user types in key as, let me see if I can really write down something like name, and then value probably will be Emad, and then you will store it like that. And next time, if the user says, I don't know, like city, and the value as Amsterdam, for example, you're gonna store it in the next block, right? And next time, when the user tries to find out what is stored as city, the program should do this. So first, we know this is the head node. We find it out. We check. No, we're not looking for name, so we can just go to the next one. Okay, we're looking for city, and this is the value. So that's how the linked lists work. But in the worst case, I'm trying to just speak about the time complexity of this data structure and algorithm. So in the worst case, the key that you're looking for is going to be stored in the last node. And that makes it really, really inefficient in terms of getting a key, right? So you have to really wait until you walk through all of the nodes and find out, okay, the last one, unfortunately, not lucky. I mean, we're not really lucky in that scenario. The last one, the last node is the one that I'm looking for. And that makes it really inefficient, not optimized. And that's where we call the time complexity of that algorithm is big O of n. Because the n is the number of the nodes that we have in the linked list. And then in average, also in the worst case, the last node is storing our key that we're looking for. So we're fucked up. That's why we don't go with the linked lists. Instead, we can do something else. We can use something like hash tables that they help us to prevent this like inefficient time complexity. Let's start reading the hash tables. I have not implemented a hash table myself, not just in C nor other programming languages. So I'm gonna be like, let's start reading it one by one together, and probably then we can just see if we can do it in C, the actual implementation. I mean, I'm gonna start with hash tables. Geeks for Geeks, and let's start. What is a hash table? A hash table is defined as a data structure used to insert, look up, and remove key value pairs quickly. Quickly, that's the whole point. It operates on the hashing concept, where each key is translated by a hash function into a distinct index in an array. The index functions as a storage location for the matching value. In simple words, it maps the keys with the value. Okay, let's start. Let's go back to the ExceLidrao and talk about the hashing. So, what is hashing? What's happening? Imagine you have a function, which I'm gonna call it h, function h, and let's say you just say name is the input of that function, and you will get a number, something like 25. That's the whole point of this hashing function. You can create your own hashing function if you're really familiar with like mathematics. You can use like ASCII codes, and there are tons of kind of solutions. You can write your own hashing function, but let's not focus on the implementation itself. But let's, on a high level, like check what is the like definition, how this, how does it work, right? That's the whole point that I'm gonna show you. So the whole point of a hashing function is you give it as an input, you give it a string, then you get a number as an output. And surprisingly, if you just rerun this and give name again as input, you're gonna always end up in 25. So there's no way that you, at some point, you call this function with name input, you get 26. That's impossible, right? That's the whole point of hashing. There's a guarantee you will end up in the same result. And so where this is being used right now in backend systems is like when you want to compare if the a password that user is entering in the login form is actually the thing that is stored in database when they were registering their account. And just for your information, hashing is non-revertible, if that's a correct word in English, I'm not sure. It means that you cannot really go back from 25 to name if you have the hashing function. And let me just rephrase it probably. Hashing is non-revertible because if you have the output and if you have the hashing function, you cannot guess what was the input. That's the whole beauty of mathematics, and also how the hashing functions work. That makes you to not to be able to like guess what a password was, if you even have the hashed version of that password. That security kind of aspect is not going to be really needed, but just for your information, that is a characteristic of this hashing functions as well, which is not being used here in hash tables. So that's the whole point. And where this is going to be really needed in our like project is that let's assume we have an array, and now when we are trying to insert something like name, right? After that, we just put it in the hashing function. We get something like 3. Then we know we can store it in this 3 here. So now that block that we were talking about, name, and the value is in this 3. So next time, if user asks me, okay, I'm looking for name, what is the value of the name? You just put it in the hashing function again, you get 3, and you know where to look at in your memory or your data structure. And that makes it, in terms of searching, big O of 1, because you already know where you have stored it. But a very big disadvantage of this hashing function is that probably you can, let me remove some parts from here. So hashing can have collisions. Like what? Let's talk about name, and also talk about like year, for example. Sometimes it's possible that you hash two different strings, but you get the same number. That is completely possible. If you don't believe me, we can do it on ChatGPT. Let me just. Is it true that given two different strings, we can end in same hash result or hash output? Yes, this is called the hash collision, and that's what we're going to talk about more in depth later. So that was just for my confirmation. I just wanted to make sure that that was the assumption was a correct one, so I'm not talking in the wrong way. So yeah, that's one of the disadvantages of using hashing functions. You can end up in the same hashed output, and there you cannot really, you know, use the same index for storing two blocks. And that's where databases like Redis does this. They create a linked list there and they store collision blocks in terms of hash output as a linked list there, and then they do a loop there. Because the chance of having that collision is very less, so that's why the linked list is going to be still efficient. Databases like Redis uses that with some tweaks. It's not that simple that I explained, but they uses that to handle the collisions. But sometimes there are like even simpler solutions, and one of the solutions is that you can simply rehash your stuff. So you can, for example, double hash something, and then you make sure you're not gonna end in the same hashed output. And that's the approach that I think we should really take. We shouldn't really create that linked list because it's going to be really complex, but probably at the end of it, we can make it an enhancement kind of task and tackle it probably if we have time. So let's continue with the documentation. This is just an illustration of the whole point that I explained it to you. We have different keys. The hash function will end up in distinct indexes or like numbers that you can use them as index numbers of the bucket or array or whatever that structure is going to be like. I'm not really interested in the load factor. Let's just do a recap of what is a hash function. A function that translates keys to array indices is known as a hash function. Not always. Hash function's definition is like that if we're talking in the context of hash tables. In other contexts, that's not the exact meaning of hashing function. Hashing function is like you do some mathematical stuff on your input and then you end up in something that you can not really guess the first input. That's the whole point of hashing, right? The keys should be evenly distributed across the array via a decent hash function to reduce collisions and ensure quick lookup speeds. The collision concept is something that I already explained, right? And these are the different types of hashing. I think we're not really interested in those. We're gonna search about those later. Choosing a hash function. Nope. Collision resolution techniques. Right. Collisions happen when two or more keys point to the same array index. Chaining, open addressing. So the chaining is the exact thing that I just explained it to you. It's like putting a linked list in one index and then you start looping over those nodes to get to the key that you're looking for, right? And double hashing, which we're going to use, are a few techniques for resolving collisions. And here's the whole point. Exactly, so 15 and 10 can result in 0 if your hashing function is not really, let's not say advanced, but there are chances of getting the same output, so you just double hash it, or you use some techniques to avoid those kind of situations. Um, Dynamic resizing. This feature enables the hash table to expand or contract in response to changes in the number of elements contained in the table. This promotes the load factor. Not interested. Example implementation. Nope, 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 nope. Okay, I'm not really interested on any of these. But let's start doing some stuff in terms of researching. Now we know what is hashing. We know how to quickly insert and also find that key value pairs in the memory. But where should we really store them? When we talk about bucket or an array, then probably we have to somehow check a real implementation in C as well. So yeah, let's just use ChatGPT for that. I'm trying to implement a hash table in C. Show me a very simple example. How can I implement it? I'm gonna wait. This is the first time it's not working. It's stupid. Okay, here's a minimal clean. Okay, thank you very much. We have some illustration again on how the hashing works, what is hashing, and here it is. Hash function simple DJB2. So here is a kind of hashing function that will help us to um, generate numbers, I think, based on the keys. Exactly. So this is a constant character pointer of a string. So let's try it in code level. I am going to. I have a make file ready in other projects, and I'm gonna use those. For example, here I have a make file, and I'm gonna copy that exactly here. Once I do that, I have a make file ready to just compile my program in C. And I'll have main.c, and I'll have int main, which returns 0 by default. And if I say printf hello world, I should be able to compile it really quickly. Let's do make. Yep. What happened? I don't know. I'm gonna run main, and there we go. We have hello world. Okay, now I will do um and I think OCD. I'm gonna be like make fclean to delete everything that was as an object output of the C program. So yeah, I'm gonna create a new folder. I'm gonna call it utils, and there I'm gonna create this hash is the thing I'm gonna just name it, and then I'm gonna have hash.h, and yeah, that's it. Um, in my hash.c, I'll be like, let me check the code again. It's like unsigned long hash. Okay, why it is unsigned? Because we're talking about the indexes, right? It should start from 0 to infinite. You cannot really have minus indices in C programming language. So unsigned long hash, okay, you're gonna get a string. And C, the way you create string is by creating a pointer to the first character of that string, and then the series is gonna be it's something like actually a linked list, if I'm not mistaken. So you just store characters in sequence, but you just always point to the first character in memory, and then you know how long it is, so you can quickly read the whole string. And then we have this unsigned long H, which is 5381, and then we have C, while C equals um okay, string plus plus, the pointer of course, and we are dereferencing it. Okay, the H is gonna be H shift left 5 plus H. Okay, I'm gonna just copy and paste it there because I'm not really interested in writing or knowing how the hashing function works. Probably in C you are going to be able to have other standard libraries that you can hash stuff. So that's not my intention for now. That's not my goal of this project. And I have totally forgotten how should I write a the header file. Let me just quickly take a look. And if I go there, I'll be like, not there. Let me open my first project, and in operations, no, in Leap 2, I want to just take a look at the node edge. That's how we do it. If not defined, node edge, defined, okay. This is a project which I was trying to implement a linked list with C. I'm just trying to get the sample how I can write a header file because I'm really new to C. So it's gonna be like if not defined hash h true. Yeah. Quickly just define hash h and define. Is that correct? No, and if. Oh, true. That was the. Okay, yeah. And between them, I will be able to just provide the signature of my function, which is this one for now. Cool. And I have to also include the Leap folder there. Wildcard, probably. What if I say star? I think. No, not sure. I think that should work. Actually, I shouldn't really change anything because source is just wildcarding any C file. Okay, I'm gonna try it. And in main.c, I will quickly include the hash that edge, or is it utils hash like that? And then I can say const character name equals emot, and I can simply say integer or unsigned long index, for example, equals hash, and name should be passed there, and printf the index. Oh, sorry. Printf the index like that. What is the error here? But that was the. Oh, right. So I'm not really sure how the unsigned long is when it comes to printf. I'm gonna just search in ChatGPT. C printf format unsigned long. LU. Okay. LU. That's correct. And let's compile it. Make. There's this issue reference from not found for architecture. Okay, so that was what I was looking for actually in the wildcard section. I'm going to simply just check the make file, and there we have this wildcard lib as well. I'm gonna copy the same pattern probably and paste it here and just turn it to utils. And if I do make re, that's working. And now you see my name, Emad, ends in this result. And if I just rerun my program, we're gonna get always the same. But if I change my variables value to something like this, and if I do make re and run the program, it's a completely different one, as you see. But that's how we find out which index we should write to and which index we should look into in order to find a key in our bucket or in the table. So that's the whole point. That's the start of this project. I'm gonna end this first episode now, and then I'm gonna continue the rest of it probably the next time when I have time. And in the next episode, probably I will try to write a interactive CLI and also the engine. I'll do some scaffolding in terms of file structures, and then writing down some utils in order to create and store values, and probably we have to also write a CLI as well. So those are the things that I'm going to try to implement next time. That was it for now, and have a nice one.